You're so brave and strong, walking through the jungle, a rifle in your hand. You're the sniper of the earth.
Okay, so for this question, we're asked to estimate 9 to the 1/3 power minus 2 using linear approximation, and then we're going to find the error using a calculator. Okay, so let's do the first step. First steps first. So we're going to estimate this value here. So let's look at it a little bit more carefully. So we have this 9 to the 1/3 minus 2, which we can actually rewrite as 9 to the 1/3 minus 8 to the 1/3 power, right? Because the cube root of 8 is 2, so we can rewrite that as that. So that means that we have something to the 1/3 minus something to the 1/3, so we can kind of deduce that our f of x is that something to the 1/3 power, so x to the 1/3, okay? So now that we have that, we can also kind of extrapolate here that our f of a plus delta x and then minus f of a, okay? So a is presumably 8, okay? So a is equal to 8, and then a plus delta x is equal to 9, right? So our delta x is 9 minus 8, so that is just a 1, all right? So it's simply a 1. So we have these two pieces of information now. Well, actually 3, right? Because now we know our function. Okay, so now let's write down the linear approximation formula. So we have L of x is equal to f prime of a times x minus a plus f of a. All right, so let's get to solving this. So we have that, first of all, let's find f of a, which is f of 8 in this case. F of 8 is equal to 8 to the 1/3, which is equal to 2. So that was pretty simple, right? So now we know that this is 2. Right, and we know that a is 8, so we'll have an x minus 8 here eventually. And now we need to know what is f prime of a. So what is, let's see, what is f prime of x, just in general? So we have f prime of x. We'll do this on the next slide, so we have more room. So f of x, our original function is x to the 1/3. Therefore, our f prime of x is going to be, according to the power rule, we bring down that 1/3, then we subtract 1 from the exponent, so we get a negative 2/3. Okay, and then so we can rewrite that as 1 over 3 times x to the 2/3. Okay, now let's plug in our a value, where a is equal to 8. Okay, and then just as a side note, delta x is equal to 1. So f prime of a, or 8, is equal to 1 over 3 times 8 to the 2/3. Okay, and that is going to be equal to 1 over 3 times 2 to the second, right? Because the cube root of 8 is 2, and then we raise it to the second power, so then we get a 4. So our f prime of 8 is equal to 1 over 12, all right? So now we have all the pieces to plug into our linearization puzzle. So we're going to write L of x is equal to f prime of 8 times x minus 8 plus f of 8. All right, so let's plug in what we know, which is pretty much everything. So f prime of 8 we just found to be a 1 over 12. So we have 1 over 12 times x minus 8. All right, and then we have a plus, and we found f of 8 to be 2. Okay, so let's just simplify from here. We'll continue this on the next slide. So we have L of x is equal to 1 over 12 times x minus 8 plus 2. So if we distribute that, we just get a 1 over 12 times x minus 8 over 12. So that's going to be a 2 over 3, and then plus a 2 all the way over there. So L of x is equal to 1 over 12 times x, and then we have a minus 2 over 3 and a plus 6 over 3. So that'll be L of x is equal to 1 over 12x, and then we have a plus 4 over 3. Okay? So now, what do we do with this? Great, we have a linear approximation, but what are we supposed to do? We're going to approximate or estimate our value of 9 to the 1/3 minus a 2. Okay? So now let's think about what does a linear approximation do? So now that we have this handy equation, what can we do with it? So what this does is it approximates, our f of x, our original function, for a value near or around our a that we use. So that would be 8. So the value that we want to find, so f of x, again, that's equal to x to the 1/3. So let's plug in a 9 and see what we get. So if our x is 9, because we want to find the cube root of 9, right? So if we plug in a 9, we get L of 9 is equal to 1 over 12 times 9 plus a 4 over 3. So that's equal to 9 over 12 plus a 4 over 3, which is the same thing as 3 over 4 plus 4 over 3, right? If you reduce it. So then if we keep solving, if we're going to combine those, so we get, if we want to get a common denominator, we'll get 12. So I should have just left that as 12. So 9 over 12, and then this one over 12 is a 16. So we end up with a 25 over 12. So this is the linear approximation evaluated at 9. So this is about equal to 9 to the 1/3 power. Okay, so what we can do now is actually just plug this 25 over 12 in for this spot. So 25 over 12. And we'll continue this on the next slide. So we're going to have 9 to the 1/3 power minus 2 is about equal to 25 over 12, and that comes from our linear approximation. And then we're going to subtract 2 away. Okay, so that's going to be 25 over 12 minus a 24 over 12. So we're going to get an answer of 1 over 12 as the difference, as the approximated difference between 9, the cube root of 9, and then minus 2. Okay, so this is our estimate. This is the estimate of the difference. Estimate. And now, so that's basically it. That is our linear approximation. And now what we have to do, the second step, is to find the error. So what we're going to do is find the error. Okay, so how do we do this? We're actually going to have to find the true value of this here by plugging it into a calculator. Okay, so when we plug it into a calculator, so this turns out to be, this is going to equal, so this is from calculator, okay, this is going to turn out to be something like 0.08 and then 0.0083823. I'm just going to go crazy with the decimals because we want it to be pretty accurate, right? Because our error shouldn't be super big. Okay, so now that we have that, this is our actual value. Actual, see how I labeled actual and estimate, right? Okay, so now to find the error, so we're going to have that error is going to equal, it's the absolute value of the difference between the actual value of the difference here, and then minus the estimate, which is f prime of a times delta x. Okay, so actual minus estimate, so this is going to be actual, so absolute value of actual, if I can write numbers correctly, there we go. Okay, 83823 minus our estimate, which is 1 over 12. And then when you plug this into your calculator, you'll eventually get a 0.00, and then 3, 2, 4, and I'll write a couple more, 9, 5, and a 1. Okay, so that is basically it. So that's our error. Okay, so this was our error, and this was our linear approximation. This was our answer. So linear approximation from plugging in a 9 into that. Okay? Alright, so that does it for this video on linear approximation and applications. I hope that helps, and happy studying.
The sun is turning red, a good job.